So the other type that we have is the linked list, and this uses a sequence of linked nodes to store the information in here. So if we jump over here, we talk about a linked list. Conceptually, what we can think of is that it has a piece of memory it stores, and then it has some sort of link to another piece of memory, and a link to another piece of memory, and a link to another piece of memory here. And so if we had something like this, 4, 8, 30, and 35, we would have 4, 8, 30, and 35 is what we'd be storing here. And in Java, it actually links in the other direction as well. So we can go backwards and forwards through this, following these links through here. So this is the start, and we'd start here, and we'd want to find something. So if we want to get to the, say, the 30, if we're on an array list, this is 0, 1, 2, 3. If I want to find the element at the position 2, so if I did a.get 2, here I just directly index in, but with my linked list here, I need to go to the start of this and then traverse this list here. So this is 0, this is 1, then I need to follow that down again till I get to 2. So it has to actually move across these nodes, and that can take time. And as the list grows, we can have some issues there. So it has a slow random element access. So if I want to access any one of these elements, if I want to access the 500,000th element, I have to step through 500,000 of these nodes to get there. Whereas in an array list, I just say, give me the one at the 500,000th position, and it immediately goes to there. So we have a bit of an issue there about slow random element access, but it has speedy insertion and removal. So if your task that you're doing is adding and removing things a lot, especially towards the front of the list, then the linked list is a great data structure to use. So basically, if we have a new item that we want to add in at the front, so if we do a a.set 0 to 10, then what it needs to do, create a new node that is 10 into here, and we can remove these links and link this one up to here, and that's all we need to do. We don't need to remove or move any of these here. If I want to remove the 30 from in here, then I just delete this node and reconnect over to here. And so that gives us, so if we remove, what's that, 0, 1, 2, remove 2, then it's very quick, whereas the array we had to move all the items, whereas this here, we just reconnect these items here. All right, so they have different characteristics. Most of the time an array list is good to use, but you may want to think about whether a linked list is a good way to do things. So collections versus standard arrays. Arrays have a fixed size. So remember we say I want it to be, for example here, I want it to be of length 20, and then it's at length 20. It's that size. It doesn't change. It's always the same size. We can't change that. Whereas an array list is similar, except it can resize itself, so it's extensible. There's no size limitation apart from your size of the RAM in your computer. We just define it without giving it a size. If you're really particular and want to tell it a size, you can, but generally we don't. And we can just start using it, add things to it, get things to it. And remember it's zero-based indexing. So get 5 returns the 6th element in there. All right, so let's do a bit of an example here. So we'll look at how we could build up an array list, and then we'll also have a bit of a play around with the different collection types that we've seen so far, and using iterator and maybe a little bit of generics explanation as well in here. We're showing you how we can use a collection, and it doesn't matter what it is, we can still print it.